All right, code security. So now we're at the Git repository. We have intellectual property, that is the source code, and we want to integrate some security controls to make it less likely that that intellectual property will be compromised. And of course, there's two threats that I want to really dive into. One threat is unintended access or theft of the actual source code. And the other threat is malware injection, where literally code gets into your software that you didn't want to get into your software. And so on unintended access, usernames and passwords, that's going to be the most risky. You can add two-factor authentication, that's your solution for the independent access. But for your, let's say your GitHub account or wherever you host your source code, you're going to have an account that has access. Use the first recommendation is to use team-based access for each repository. Don't grant access to individuals, because then when that individual leaves the team or changes roles and you need to remove them, now it's up to separate record keeping for what team they were on and what Git repositories they now don't need access to. And so if you use team-based access, then that record keeping is baked into it, because the ABC team will have access to these 7 Git repositories. So if they're removed from the ABC team, then instantly they get the proper repositories restricted. And then you also want to go through every now and then have a schedule for the removal of non-active committers or readers, especially readers. Oftentimes somebody needs to do a review or have temporary read-only access to the code. And unfortunately, I'm not aware of any tools that say, oh, give someone permission or give someone access with an expiration. So we have to remember to expire these and take that away. All right, on the malware injection, static code analysis is your friend. SonarQube has features that inspect security and also inspect security vulnerabilities of NuGet packages that you happen to rely on, not just your code, but the code of packages, because there are so many packages with known vulnerabilities, and many of these packages are patched and the vulnerability has been fixed, but only if you upgrade the version of that particular package. Now, you do not want to have a blanket greater than or equal to on the version, because that right there is just opening you up for all kinds of attacks, like what happened in the fall or last year with NPM, with the UA parser.js hack. And NPM, there's been a number of these in NPM, and I think it's just a matter of time before it happens at NuGet as well, where there's some open source project that has some committers' credentials compromised. And guess what? Good open source projects have continuous integration with automated functional tests and automated publishing of new libraries. So you don't actually have to have the package manager's credentials to publish a new one. If you just get a committers and, oh, we're accepting this pull request along with some nefarious code. And so that can happen. And so you want to make sure that every change to your code, which includes versions of packages, insist on pull requests so that people are taking, and put review of dependency changes on the checklist by which you approve pull requests. Okay, that gives you more chance to detect if we're upgrading a version of a package, but we really hadn't planned to update that version. Also, again, I said this already, you don't want to have blanket greater than or equal to version number on your package references in NuGet. You want to make sure to reference a particular version and update intentionally. Have a person update it, because a nefarious hacker, when they publish a new version of these packages, they're not going to do a major revision and say it's version 3 instead of version 2. No, they're going to say this is version 2.45.1. And so it's really popular to have greater than or equal 2.45 dot star, so that we can just automatically get these minor patches. Well, guess what? The hacker is going to classify whatever they did as a quote minor bug fix, so that all these people that have these greater than or equal to version dependencies, guess what? They just automatically get this new version with the bad code. So be aware of that. Okay, so let's talk through just the general structure of what your build flow should look like in your DevOps environment, so we can talk about where security fits. But your private build and your continuous integration build, they're going to share the build script, and they're going to do a lot of the same things. They're going to clean the local directory of past build artifacts. They're going to stamp a version number. They're going to create the database that's used for that particular build. They're going to do the compilation. They're going to run unit tests and component level integration tests. But your integration build continues on and runs your static code analysis rule sets. And you should not only run the analyzers, the not FXCOP, but your Roslyn analyzers. Now, make sure that you select the rule sets and add additional rule sets. SonarQube, Independ. There are so many static analysis rule sets out there that are security checks. There's really no reason for not using them. A lot of them are free and so affordable. And so the integration build, you really need to have that package bundled in. But the integration build continues on, publishes test results, and then packages up the deployable release candidate packages and publishes those out to Azure Artifacts or GitHub or wherever you do it. Then when one of your developers has done that, and you actually have done the committing and we're on the master branch, this is the flow of a pull request. And when I say add security related things to your checklist by which you do your pull request inspection, I really literally do mean to elevate your pull request process up to the status of a formal inspection. Capers-Jones in his research has shown that there are 3 quality control methods that reliably elevate teams' delivery quality up to the high 99% defect removal before production. And the one of them is testing. One of them is static analysis, and the other is formal inspections. So testing, if your team is doing test-driven development and continuous integration, then you are doing the testing that is shown in the research. And make sure you're doing all 3 levels and more of automated testing: unit tests, component level integration tests, and full system acceptance tests. And then static code analysis, we talked about that. And the third is formal inspections. A pull request checklist is the most practical implementation of a formal inspection. When someone has done something on a branch and they're ready to push it into the master branch, well, guess what? You got an inspection. And instead of just saying, oh, the coding style, and I like what you did, no, make it a checklist. If really highly trained people like doctors and airline pilots rely on checklists, then we can too. And so just decide what the checklist is going to be and put it in there and have everybody just, when they click that button, accept pull request, it's saying, on my honor, I have verified that the changes represented in this pull request do in fact satisfy all of the items on this checklist, and I'm clicking the approve button. And you know what? During your normal retrospective process, when you talk about it, you ask the question from time to time, whether it's based on a bug slipping through or something. Hey, is our pull request inspection checklist still sufficient, or should it be changed in any way? All right. And if you want to change it, you change it and you move forward.